Welcome to Math Tutorials. In this video, we are solving every question of exercise 3.3 of Chapter 3, Matrices, from the NCERT Mathematics textbook for Class 12, Part 1. Exercise 3.3 has 12 questions on the transpose of a matrix, transpose rules, symmetric and skew-symmetric matrices, and splitting any square matrix into a symmetric plus a skew-symmetric part. Here are the questions. Let's begin. Question 1. Transposing swaps rows with columns, 3 matrices to flip, a column, a 2x2, and a 3x3. The column becomes a row. For the 2x2, row 1 becomes column 1, row 2 becomes column 2. Same rule for the 3x3. Each row lies down as a column. Question 2. 2 3x3 matrices, and the rule that transposing distributes over addition and subtraction, verified by direct computation. We compute each side of both identities in full. First a plus b, every entry written. Transpose it, rows become columns. Now the right side. Transpose A and B separately, then add them entry by entry. Part 2, the difference. A minus b with all entries written, then transposed. And a transpose minus b transpose gives the identical matrix. Both rules verified. Question 3. This time we are handed a transpose, not a, so first we recover A itself. Then the same 2 rules, verified in full. Transpose a transpose to get a back, a 2x3. A plus b, entry by entry, then flipped. The right side, a transpose plus b transpose lands on the same 3x2. Part 2 with the difference, both routes give the same matrix again. Question 4. Again, A is given through its transpose, and we want the transpose of a plus 2b. B is given directly, so we recover A, combine, and flip. Recover A by transposing. Scale B by 2 and add, all entries written. Transpose the result. Question 5. The reversal rule. The transpose of a product is the product of transposes in the opposite order. 2 column times row pairs to verify it on. Pair 1, the column times the row blows up into a 3x3, every product written. Transpose it. Now B transpose times a transpose. A column times a row again, every product written, the same matrix. Pair 2, the same verification, a B transposed. Equals B transpose times a transpose, entry for entry. Rule verified twice. Question 6. 2 rotation-style matrices whose transpose undoes them, a transpose times A should give the identity. Multiplying each by its own transpose should collapse to the identity. Case 1, write the product with every entry as its 2-term sum. Diagonals are won by the Pythagorean identity. Off-diagonals cancel, the identity matrix. Case 2 runs identically with sine and cosine swapping roles. The same cancellations, the same identity. Question 7. Symmetric means the transpose equals the matrix. Skew-symmetric means it equals the negative. 1 matrix of each kind to check. Transpose the first matrix, rows become columns, and it comes back unchanged. Symmetric. Transpose the second and every entry flips sign, it equals minus A. Skew-symmetric. Question 8. Adding a matrix to its transpose symmetrizes it, subtracting skews it. Verified concretely. We compute both combinations explicitly and transpose them to check. A plus a transpose, entries written, and its transpose equals itself. Symmetric. A minus a transpose, and transposing it flips every sign. Skew-symmetric. Question 9 with a twist. Look closely and it is already skew symmetric. These are the symmetric and skew parts, but watch what already is. A transpose flips the signs of a, B, and C, exactly minus A. So a plus a transpose is the 0 matrix, and half of 0 is 0. And a minus a transpose is 2A, whose half is itself. Question 10, the decomposition theorem in action. Any square matrix is half of a plus a transpose, plus half of a minus a transpose. 4 matrices to split. Part 1, the symmetric part averages opposite entries. The skew part takes their half difference. Check, P plus Q returns the original. Part 2 is already symmetric. Its transpose equals itself, so the symmetric part is A and the skew part is 0. Part 3, both halves written in full. And Part 4. Question 11. A and B are symmetric. We test the commutator of B minus B by transposing it. Transpose the expression, using the reversal rule on each product. Symmetry replaces the transposes. B a minus a B, the negative of what we started with. Skew symmetric. The final question. A rotation matrix, whose sum with its own transpose must equal the identity. Adding the transpose doubles the cosine diagonal, and that must equal the identity. Add it to its transpose. The sine terms cancel, leaving twice cosine alpha on the diagonal, equating to the identity. 2 cosine alpha equals 1, so cosine alpha is 1/2. So alpha is pi by 3. That completes exercise 3.3. That completes all 12 questions of exercise 3.3. In the next video, we will take up exercise 3.4 and the idea of invertible matrices. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.